Okay, so you're an indie developer, you decided to make a multiplayer game. The objective of this video is to give you some guidance, some starting points on what to Google and what to implement to try it out first, so you can decide how your multiplayer game is going to be. Maybe, change the multiplayer type of the game a little bit because it might be too hard to make it. So let me first begin with how it works. The sole objective of a multiplayer game is to share a simulation of the world between all the players. And to accomplish that, what you do is very simple. You get things in the world like a door, an object, a player, an enemy, and you need to share with other clients the state of those objects. And there's so many ways of doing it. And each with its pros and cons, each with its own limitations, and each with its own costs and problems. So it's very important that you select the exact and perfect multiplayer game type, like multiplayer model, to implement your game. And this is kind of why there's no silver bullet solution for multiplayer games. Each type of multiplayer game is going to wildly differ from each other. For instance, a co-op game will be very different from a completely competitive shooter game, for instance. And a shooter game will be completely different than a fighting game. That will be completely different from a racing game. That will be completely different from an RPG and MMORPG game. And there's so many types of games, and they all have their own types of netcoding. So the first thing you've got to understand is what kind of types of games are extremely tough to implement and what kind of types of games are super easy to implement. And based on that, you can probably make an informed decision. And the last thing you want to do is get an Unreal Engine that has a netcode mainly suitable for shooters and maybe some battle royales and try implementing a racing game on it, a card game on it. That would be completely insane, and you would be wasting a lot of resources, or maybe getting something that doesn't really work that well for a type of game. So here you're going to learn how to spot what kind of netcode you're dealing with and what kind of netcode you need to implement for your own game. Okay, cool. So the first type of multiplayer I would like to introduce is the simplest one. So it's one that a lot of people think, oh, I'm not going to do my game this way because it's going to be multiplayer and that's super hard, that's super expensive, it's going to be really tough, it's impossible, I'm not going to do it. Co-op games. Co-op games are extremely easy to implement. And the reason being is, remember in the beginning I said multiplayer games are basically a way of sharing the world with other players through sending networking packets. It's only relevant to have a server handling all that if your game requires to prevent cheating. If your game doesn't require cheat prevention, you can implement the simplest netcode of your life. And what do you mean by that, Gabriel? Like cheat prevention? I don't want to cheat in my game. Do you really don't? Like, for instance, a co-op game, if someone's cheating, you just quit the lobby. Just try finding another party and the dude's not cheating then. And then you just do it, Like, co-op is fine. It's like preventing cheat on a single player game. You really don't need that, right? So with co-op games, you can just send the data directly to another client. And the data doesn't have to be double checked or processed or whatever. You literally just get the data, send it, synchronize, we're good. The game's multiplayer, and that's done. And just sending data over is extremely simple. What gets really complicated in multiplayer games is when there's a server involved. So you have to pay for something, you have to have a server browser, you have to have maybe matchmaking, and then the server has to simulate the game to make sure there's no cheating, and then you're going to pay bank for the server, and it's going to be a really complicated business model. So if you have a co-op game, do not worry. Just throw some Googling around and you can implement some way of sharing the state of the world, and cheating could happen, but if it's not a problem, yep, great. Another really easy type of game, I would say, is something like a card game. And the reason it's easy is because the communication of the server is going to be very sparse. Like, it's only going to happen every action of the player. And then a card game is like once per a minute. So it's fine. You're not going to pay almost anything to host servers, right? And not only that, you can use web development technologies that are widely available, and there's way more developers proficient with them. And then you can get some really cheap developers to build a web server for you that makes your card game works. So I think those two are super easy to implement. Remember that. Any game that doesn't care if people are cheating or card games, you can do it. Just go ahead. Don't think it's hard, because it's not. Do some Googling, how to make a card game server, or how to make a co-op game, or even how to send data over the network. And then you can make a co-op game. That's all you need. It's really not that complicated, so I highly suggest you go and try. And what you can do some research on is, for instance, some things that could make your life easier for a co-op game. You can research about the Steamworks P2P library. Basically, the Steamworks is the Steam online subsystem SDK. You can download that, integrate on your game, and then they have like a peer-to-peer kind of library, like API, that you can use to communicate between two players. And then it saves you a lot of headache. It has relays, Valve relays, and everything just works out well. So that's a pretty easy way of like just make your game co-op. And it is a lot less hassle than making a competitive shooter like Counter-Strike, right? Okay, so you decided to make a cheat-free multiplayer game, and you're going to go the hard route, and you like it. It's a good challenge, or you're already familiar with a little bit with networking and low-level programming. I'm here to help as well. So the first thing you got to understand is, now that the game has to prevent cheating, it can't just send the data from client to client, because one malicious client could be sending the wrong type of data, the wrong data, and could be lying. He could straight up say, I have a million health points and I'm never going to die. So this is not viable, right? So now what you got to have is a server. And this server is what we call an authoritative server. The server is the authority that says, this is the game state. This is your health. This is your enemy's health. You did hit the enemy. You did not hit the enemy. The server is the boss, okay? With that in mind, the server has to run the game. You literally have to run the game. And that is, as you know, games are not easy to run. So you're going to be paying a pretty penny for servers. And that's where the big bad about games, about multiplayer games comes in, especially indie multiplayer games, is the business model have to be really strong. If you think about it, servers you pay monthly, right? You pay every single month, you're paying for servers. While players, if it's a purchase game, like they only pay once. So this becomes a pretty interesting problem, because if the player spends $5-10 on your game, but he uses servers for the rest of his life, they're talking about hundreds, you're going to be paying players to play. And that's really bad. I like making games, but we have to sustain our families, right? So we have to pay our bills. So you really got to think on the longevity of the game and how you're going to maintain the business model. Many multiplayer games nowadays, what they do is they do microtransactions. They have a store with skins or even pay-to-win things in the store that you can buy. And then that's how they pay the servers and pay the employees, right? Another one is subscriptions. That's how World of Warcraft does it, actually. And there's other games as well, subscription-based games. There's Battle Pass games. There's all sorts of games, but not a lot of them are pay once, play forever kind of thing, because that's going to create a problem. There are some good examples of pay once, play forever kind of games. A good example is Escape from Tarkov. The problem with Escape from Tarkov is the way they kind of do their business model is, from what I can understand, is cheaters are going to use cheats. They're going to ban the cheaters. The cheaters has to buy new accounts. So that's how they keep fomenting the game. It's basically cheaters buying accounts over and over, which is not the greatest business model I've ever seen in my life. So first thing you're going to think is, you're going to make this type of game, you got to figure out a way of paying the bills, okay? Don't think that game is going to be super popular and you're going to pay the bills instantly. It's going to be fine. Everything's going to work out. I would, that make not exactly how life works usually. You could pull it off, but it's very unlikely, right? You got to really give a lot of thought on how you're going to do it. Not only that, this is actually why it's very important to make the server as efficient as possible. Usually through using low-level languages like C and C++. Unreal Engine provides you with the tools to develop a server purely in C++, and you might want to do that. Not only that, it might be very important to do stuff like making sure any AI that runs on the server side is super optimized and doesn't waste a lot of resources, right? So that's the first thing you got to think, how you're going to keep the lights on. And it becomes much, much easier to come up with a business model if you make the server as efficient as possible. That's also one thing you could think of. Like, how do I make the server as efficiently as possible? For instance, a good example, Counter-Strike servers runs at 64 hertz, right? 64 FPS basically. And some competitive servers even run at 128. You could do just run them at 20 hertz. It's not great. It's not going to be the greatest user experience in your life. It's going to be the best competitive shooter ever made, but it's decent and it runs well, and you can maintain. You can pay the bills, no problem. It's going to be much easier to make a game launch. Okay. Second problem, you need players. So if you make a multiplayer game and it's like a 10 player match with 5v5, you need at least 10 players to make a match happen. If your game doesn't have a good population from the beginning, people might join the game, see there's no one playing, oh my god, I cannot match make, just leave the game. And then the second player comes in, there's no one in, leaves the game. You got to really get 10 people at once, and that's not an easy feat. So do remember that. Maybe try thinking your game as a 1v1, 2v2, 3v3, something a little bit easier to make the full lobby come in, right? Third problem you're going to have is, how do they find the servers? The usual way of indie games to do it is using a server browser, right? You literally just list all the possible servers, the player selects one and goes. That's not the greatest user experience because you're going to have some servers with like 2 people, some servers with 3, some servers with 5, and we could have full servers all around. And to have full servers all around, what do you do? Matchmaking. So maybe it might be worth thinking of, how do we want to do the servering, right? Do we want to hire a web developer to develop a matchmaking system, or do we want to go and make just a server browser, just throw people at it and call it a wrap? One thing that could make the business model much easier is enabling the community to run servers. The problem with that is, if you ever leak your server code, so meaning some hacker or someone gets a grip of the server binary, or even the worst, the server source code, they can host their own versions of your game and they can pirate it. So no one has to buy the game anymore. They just connect to this pirate server and play the game. A good example that a lot of games do is partnering up with host providers and giving the host providers the binary and enabling users to rent machines that already have the server pre-installed. But the users themselves, the community, is not going to have access to the server binaries. And that way you could enable the community to run their own servers with their own mods, own configurations, without ever leaking the binary. And that helps so you don't have to host all those servers and pay by them for yourself. Another thing you have to keep in mind as well is there are different types of multiplayer games. There's fighting games, racing games, jet games, shooter games, there's RPGs, and they all have widely different types of multiplayer implementation, right? Let me begin with a good example. Shooter games, that's my favorite type of game. They're really complicated to implement, mainly because if you think about it, when the player sends for instance, the player wants to shoot an enemy, the player sends the shooting command. It's going to take a while to reach the server. So what the player is seeing, and the moment he presses the click button, it takes a while for the shooting command to reach the enemy. And when you reach the server, the enemy has already moved. So the player that shot is going to miss. And that's where the whole hit rag, like missing situation comes from. So what you got to do in the server is you got to go back in time. You got to literally translate everyone back in time, simulate the player shooting, and then check if the shooting actually hit someone. So, and that's a super expensive thing to do in CPU cost, and then eventually, because you pay by CPU, it's dollar cost. So it's literally expensive in money to make this, and you gotta make it. Otherwise, if there's a target moving, no one's ever gonna hit anything. So then you gotta do I think in PUBG you had it a little bit in the beginning. You had to shoot people way far ahead so the shot will actually connect. So that's already a big, complicated problem. Not only that, if you stop to think about it, characters have animations, right? They like be doing things like that. So let's say when the player shot the enemy was like that. But on the server, the enemy's already like that. And if the player hit this hint here, you got to go back in time on the enemy animation to make sure the hint is this way so the shot goes to land. That's crazy expensive. So first thing you got to figure out is how much precision do you want to be in your shooter? If you want to like something like Escape from Tarkov, PUBG, maybe the player really hits really well in the center of mass, then you go ahead and hit, otherwise just never mind. Then you maybe can get away with not running animations at all. Or maybe just have animations for the collision and the colliders and not really the full mesh of the player. So you really got to think on how much precise you want to make a server. But do bear in mind, if you don't do the go back in time situation I just described, no one's going to ever shoot a moving enemy. So that's one of the biggest complications. The second complication is, On a shooter, you demand, like the players will expect some kind of responsiveness. When the player presses W, he expects his character to instantly start moving. He cannot wait the server to, you send the W command, forward command to the server is going to calculate the player new position and then come back and then you move the character. That's not going to happen. It's going to be so slow, players are going to hate your game. So what you got to do is something called client-side prediction, that when the player presses W, the client already moves the character and then sends the move command to the server. The server is going to do the whole server simulation situation and then going to reply to the client, oh, by the way, when you pressed forward at that time, you came out to this position. And then on the client, you confirm if you calculated the exact same position. And if you did, that's great. Everything went right. But there could be some stuff that makes the player actually desync from the server, something like a moving object that the player bumps on. And on the client, the player did not bump, he cleared the object. But on the server, the object was already a little bit far ahead and the player did hit the object. So there's going to be some desynchronization, some disagreement between the client and the server. And that's where it comes in server reconciliation. And what it does is, instead of when the command comes, the correction comes back from the server, instead of just snapping the player back on where the disagreement happened, the client will snap the player back where disagreement happened and reapply any inputs of the player between this difference of time of where the player is already at and when the reconciliation, the correction from the server came. And that enables the player to be slightly corrected instead of a full rubber banding back, right? And you can see some games don't do that. Some games will rubber band you straight back in the day, and then you all of a sudden way back like when you were before, like 10 minutes ago. That's a server that doesn't implement server reconciliation well. So you can see I already talked about server reconciliation, client prediction, and I think I didn't mention lag compensation. Lag compensation is when you move everyone back in time so the player hits the right target. So do some researching on how to implement all of those and you have a really good shooter in your hands. One final recommendation I can give on shooters is don't try making cheats really hard to be performed. If they can't be made impossible, don't waste all your resources, all your time trying to make a cheat really hard to make, because people are going to make a way around it. For instance, things you could easily prevent. Speed hacking. I can give you some links. Just throw a comment below. I can reply with some links. You definitely can prevent people from making possible shots. So shooting someone through a wall or something. Once the server can easily verify, does this shooter and given this enemy position, did this shot cross any collision things? And that's super trivial. But you should not try wasting all your resources on trying making wall hacking possible. Stuff like checking if a player is seeing an enemy and only sending the enemy data to the player when the enemy is visible. That's going to take a lot of your resources. That's going to make the server really more expensive, and it's still going to be kind of doable. And it's going to create a lot of artifacts where the enemy is only going to show on the player screen after they're shown for they have like a bigger part of their arm showing, of their body showing, and then the enemy already shoots the player doesn't even see them. So don't try that too hard. Do the right thinking. Is what I'm doing going to make this kind of cheat impossible or just hard? Because if you're just making it hard, I wouldn't waste any time, especially don't waste server resources. Don't make the server much more expensive with a lot of checks for something that's not going to be made impossible. What you need to invest the time is try getting some good anti-cheat on your game, something that makes reverse engineering really hard, like running obfuscation on the binary. So try just preventing, on a shooter at least, try preventing speed hacking, try preventing people from shooting through walls, teleporting, those really hard things that are going to destroy everyone's experience, while applying anti-cheat on the game to make sure people are not using aimbots and wall hacks. So that's my last piece of advice, and good luck on your shooter, dude. I can throw another type of multiplayer game as well, racing games. I think the only technique I know racing games will use is something called dead reckoning. And what it means is, basically because cars mostly go straight, and then when they turn, they just do little turning, right? They don't completely do a 180 all of a sudden. Not what cars do, right? Mostly. So what you do is you always expect cars to be moving straight, And then when a message comes from the server that a card turned, you just move them a little bit back in time and then turn. And that's why in some games, when someone is really, really lagged, it shows them going straight, and they completely miss the turn. And all of a sudden, they go back and then turn correctly. That's because that reckoning was applied on a really laggy player. And I think that's the only thing you really got implemented in racing games. Just mind collisions are really finicky in racing games. So you might implement some kind of smoothing, some things to make the players not collide when they think they would. And the favorite type of game for indie developers, the MMORPG, everyone wants to make one, right? Oh man, that's a complicated one. And the main reason is, on the multiplayer games like shooters, fighting games, jack games, racing games, they all mostly have like 20 players at most in the lobby. Sometimes we have 60. That's quite a lot of players, but not quite MMORPG level, right? Sometimes you can have hundreds of players in the same location. And the biggest challenge with that comes, you can't just send everyone to everyone. You can't just get a player data and send to every other player in the map. You got to be really selective to who you send the data to. Otherwise, you're going to be having terabits of bandwidth required for the game. So what you have to do is run an algorithm called closest neighborhood search or nearest neighborhood search in an S, I believe. And to implement that, you got to implement a really efficient spatial data structure, something like a KD tree. And those are very complicated algorithms to implement, and especially implement them efficiently. So if you think you are, capable of implementing those, go ahead. It might be totally doable. But remember, it's the most expensive type of server of them all, because all the types of games I just mentioned, they just send every player data to every other player data. There's no need to run any other algorithm on top. And now you're going to have to run closest neighborhood search, that even if very efficiently implemented, it's still much more expensive than just selecting and sending every other player. So that again makes the business model even harder, right? So you really got to think on how you're going to keep the lights on. And that's why World of Warcraft did a subscription model for World of Warcraft. They really had to pay the bills, and their bills are super expensive, right? And on MMORPGs, you're also going to need a database server, a backend server. You're going to need a lot of servers, dude. And most probably going to need some sort of matchmaking server, and things get really complicated real fast. So if you think you have a really good idea, really good marketing, really good investment, really good engineers, like all of that checks out, you can do it. Probably, maybe, hopefully. So yeah, go ahead and try. Just bear in mind the business model is going to be much more complicated. And remember here, most of the time when I'm saying multiplayer games are complicated, I'm not saying that they're hard to implement or make. They're hard to make stick. They're hard to make profitable. And then making them profitable is also an engineering challenge, because you're going to make the servers as efficient as possible. And making things as efficient as possible, especially in 3D games, is really not easy. So it's both a business model and engineering challenge at the same time. And the easier the engineering will be for you, the easier will the business model be for you. So it's kind of a hand-to-hand kind of situation. You're really going to have really good marketing and business people, and also really good engineers. It's definitely possible. Don't get me wrong. But do make your due diligence and make sure you're capable and ready for it. And finally, I want to mention as well fighting games. Fighting games, you can do some Googling around the lockstep model. And all it means is usually it's a much more precise server simulation. Instead of each player having their own simulation, the server their own simulation as well, and you go back in time when someone fires or something like that. No. Everyone's on the same kind of time step almost. And that's why in some games, if a user disconnects, the other user, which is still playing the game, kind of freezes in motion. That's because it needs both of the clients to be connected and sending commands for the server to run a frame. And that's about it. It's a pretty easy type of multiplayer game. Another type of multiplayer game I want to mention as well are MOBAs. So MOBA is also a somewhat easy multiplayer networking model to implement. The reason being, one, it's much cheaper because it doesn't have to run physics. So on a MOBA, when you right click and tell a character to move somewhere, instead of running physics and calculating, this slope and collision and whatnot, it just uses a nav mesh for any AI. So it's a navigation mesh. It's just a simplified version of the level geometry that enables characters to make a path to go somewhere else without relying on calculating really complicated physics. So it can get really cheap. And you can even see like the earlier versions of League of Legends, it doesn't have any kind of client-side prediction. When you right-clicked somewhere, if you had like a really high ping, like 300 milliseconds, it would literally take a bit for a character to even start moving. So they had no client-side prediction at all. They did mask some things, like when you use an ability, usually on the client, it starts casting already, but then it takes a minute for the ability to actually start casting. So you would give the player the impression that things are actually running locally and really fast, but it's actually coming from the server after a while. So MOBAs are fairly easy to implement. The servers can get really cheap and you can get really good results with it. I highly suggest you give it a roll. You're still going to have to pay for servers. You're still going to have the whole infrastructure challenge and matchmaking. So do bear in mind, it's not as trivial as making like a co-op game with P2P. Okay. And to expand a little bit more on the card game situation, or games where there's not a lot of movement, like a chess game, like a checkers game, something that people just do small movements each time. You don't have to implement like a C++ or C# server. You could literally get away with just implementing a Python web server and making API calls. And that's going to enable you to hire really cheap developers or to make the development lifecycle really easy and really fast. So do bear that in mind. If it's a card game, a really slow moving game with not a lot of actions happening, no need to calculate physics, just make an API, literally a web server. Maybe if you want to make it real fancy and make it really responsive, implement a WebSocket server and call it a rep. It's really that easy. Lastly, I want to expand a little bit more on the C++ situation I mentioned. The thing is, it's about making the server as efficient as possible. That's going to make a business model as easy as possible. That's going to make your game as easy as possible to make it thrive. That's going to enable your team maybe to have more profit so you can hire more people and make a better game. It's not about elitism or making sure things are as fast as possible because we want them to be. No, we're not talking about clients. Clients, they run on their own computers, pay their own electricity bills, they have their own machines, they're going to fail. You're going to have to pay monthly for servers, dude. You're going to make it efficient. You can make just something that kind of runs on servers. Your game is going to be destroyed. It's not going to survive. If it's going to run for a bit, and then you're going to run out of money and shut down the servers. You cannot do that. And the reason being, C# and other programming languages, they have a garbage collector, and that destroys performance for many reasons. They can make the server stutter, they can make the server costs way higher, they can make the memory usage much higher. So C++, yes, it is much harder to use. You're going to have to learn a new language. It's harder to program. It's harder to do anything. But it's going to make your game viable. If you cannot make your game viable, why are you making a game in the first place? So here, I don't want to make like a case that everyone should learn C++ and that's the only way of making games. I just want to say use the most efficient language possible. And if you have an incredible business model, like a mobile game that people are going to be buying skins that are going to be flying off the shelves, yeah, maybe C# could make it stick. And if it's a simpler game, much simpler game, a card game, some games they're like an idle game, some games that don't have constant server simulation of physics and etc. Maybe you can make it stick for sure. But if it's a shooter game with animation simulation, going back in time to simulate each bullet when a player fires, I don't think you have a lot of luck without C++. So do give it a roll. You can use Rust. You can use any language that's going to make your server efficient and your game business model viable. So that's about it. It's not about preference. It's about money and real life. Okay. I hope you leave this video knowing more than you did before. My objective with this is give some guidance, some like keywords so you can Google around and figure out your way around the objective of your project. If you have any questions or comments, please leave them below. I'm going to try my best to answer them all. And I do think it can help with almost any type of multiplayer game. I can give some suggestions where to look at, what kind of cost, what kind of model, what kind of approaches you could take. So please, if you have any questions, leave them below and I'm going to do my best. Hope you liked it. If you could leave a like, subscribe, and have a great day. Yeah, boy.